In order to determine the end behavior of polynomials, there are two key pieces of information that you need. The first piece is you need to know whether the degree is even or odd, and your degree is the highest exponent. And you need to know whether the leading coefficient is positive or negative. And your leading coefficient is the number that's multiplied by the term with the degree. So with polynomials, there are only 4 cases that you can possibly have. One case is that your degree is even and your leading coefficient is positive. So with the red graph, our degree, the highest exponent, is 2, and our leading coefficient, the number that's multiplied by that term, is going to be 1. It's positive. So when we're looking at the red graph, what we notice is that on both ends, our graph is going in the positive direction. Our graph is continuing to go up. What you also notice about the graph in blue is that its degree is also even, 4, and its leading coefficient is also positive. So anytime you have an equation or a function where your degree is even and leading coefficient is positive, then on both of the ends, they're going to do the same thing. They're going to rise. If you have a polynomial where your degree is even, but your leading coefficient is negative, as we see in these two cases, then what's going to happen to your graph is that on the ends, it's going to be going down. It's going to be falling in both of those directions. So even degree, leading coefficient is positive, your graph rises on both sides. Even degree and both of your leading coefficients are negative, then your graph is going to fall on both sides. So that's 2 out of your 4 cases. If your degree is odd, as we see in these 2 problems, and your leading coefficient is positive, what happens is on the left of your graph, it's falling, but on the right side of your graph, it's rising. And last but not least, if your degree, the highest exponent, is odd, but your leading coefficient is negative, then your graph is going to, on the left, be rising. It's at the top of your graph, and on the right-hand side, it's going to be falling. So the notation is the key. We have to tell what happens on both sides of our graph. So on this side, this is our x-axis, and this is the positive side. So this is as x is approaching positive infinity. That's the right side of our graph. And over here is x is approaching negative infinity. And what we have to do is to tell what is going on with our graph on both sides. So as x is approaching negative infinity, as we're looking at the graph on the left-hand side, our graph is going up. These y values are increasing on this side. So y is going to be approaching positive infinity as x is approaching negative infinity. We also have to tell what's happening on the right side of our graph. So as x is approaching positive infinity, as we're going this way on the axis, what our graph is doing is it's going down. The y values are getting smaller. So our notation for this would be y is approaching negative infinity. So once again, in behavior, you have to tell what's happening on both ends of your graph, what's happening on the left side and what's happening on the right side. Let's see another example. In this case, if your degree is odd and your leading coefficient is negative, the reverse happens. So we still have to tell what's happening on the left side of our graph. So as x is approaching negative infinity, as we are looking at the left side of our graph is now down here. So that means our y value is approaching negative infinity. We have to tell what's happening on the right side of the graph as x is approaching positive infinity. y is approaching positive infinity. And you could see this written backwards as well. It just depends on which textbook you're using. So they could say x is approaching positive infinity as y is approaching positive infinity, as x is approaching negative infinity, as y is approaching negative infinity. If your degree is even, your leading coefficient is negative, as x is approaching negative infinity, as we're looking on the left side of our graph, y is approaching negative infinity because our graph is going down. As x is approaching positive infinity, we're looking at the right side of our graph. Our graph is also going down, the y values. And this will always be true if your degree, the highest exponent, is even and your leading coefficient is negative. And if your degree, the highest exponent, is even and your leading coefficient is positive, as x is approaching negative infinity, our graph is rising. As x is approaching positive infinity, our graph is also rising.